This is Elijah, and this is my Barbie Bungee jump screencast. And we weighed our Barbie, and she weighed 128 grams, and we converted 128 into point 128 kilograms for our Barbie's mass because whenever we do mass in any formula, we use kilograms. And when our Barbie was fully stretched after we dropped her, she was 43 centimeters above the ground. And so we converted from centimeters to meters because in any equation we use meters, not centimeters. And how much our body stretch was 67 centimeters. We converted from 67 centimeters to 0.67 meters. And Barbie's overall height for her jump was 289 centimeters. We converted that into meters and it came into 2.89. So Barbie's gravitational potential energy before she jumped was 3.625216 joules, and Barbie's gravitational potential energy when she was fully stretched was 0.539392, and Barbie's kinetic energy before she jumped was zero. The reason it's zero is because she did not move, and she wasn't moving at the time. And Barbie's kinetic energy when she was fully stretched was also zero because in order for it to be fully stretched, it has to go all the way down, stop, and then be brought back up. And Barbie's elastic potential energy is zero because she wasn't moving at all. The and the formula for elastic potential energy is 1/2 times the k constant times how fast it was moving squared. And she was not moving at all, and anything times zero is zero. And in order to find out the US so I could find out Barbie's spring constant, I had to use the law. I used to use the formula for energy conservation, and I put my UG at the top was 3.625216 plus my kinetic energy at the top, which was zero because she was not moving, and my elastic potential energy at the top as well because it was zero because she was not moving, and my gravitational potential energy at the bottom is 0.539392, and my kinetic energy is zero because she was not moving at all. And it's the same thing. And US is US because we're trying to find it. So if we add it up, we get 3.625216 on one side and 0.539. I mean 5393392 plus US. And so we subtract the two, and we get the US, which equals 3.085824 joules. So we plug that in into our elastic potential energy formula, and we get our spring constant, which is 13.7483804856 newtons per meter. And we use 14 rubber bands to give it a thrill of a life. And this is our diagram to show where we got our numbers from. So I hope y'all enjoyed this. Oh, ho ho. And this is the reason why we chose 14 rubber bands instead of some same number like 18 rubber bands. And the reason we chose 14 is because 289 is right here, and we just slide it over. Just keep sliding until we intersect with the line, which is right here. And then we go down, and we are near 14 rubber bands. And I wouldn't want to use 16 because 16 is up here, and that would be 325 centimeters. But we're not that high, and my body would have been dead. So hope y'all enjoyed this.